Yeah, everybody loves to show your lovely face. Yeah, one more thing. Take on your attendance. Okay. If that's the case, yeah, I think we try to start earlier. I believe by 11, probably we'll be able to cover all. And then it will be a time to prepare your, what do you call that, your reports. Okay, so I don't think I need to have that, what do you call that, the manual. Okay, we have, this is the molecules, right, or compound. So this is a CN, right? So then we have the CM prime. So M prime smaller than N, right? And I write. So the third column, what is that? Guys, could you please remind me?
I.
Inversion.
Inversion center. And then sigma V, isn't it?
NC2
NC2 perpendicular to CN. Okay, and then we have the next one, sigma V, right? Sigma H. Sigma H.
H. D.
Sigma V or D? V.
D.
Okay, okay, as usual. And then sigma V, then the S2N, right? SN. Is it so? SN?
Yes.
Then we have this point group. Okay. So, guys, as I told you before, that some of the compound, you know, the TD, that day I give you the extra one. I want you to do the drawing and include it in your reports. Okay. So, and also I have shared you the links. I mean, you know, if you're having problem to draw, you can always use the CamDraw. I mean, the CamDraw, is it the one I share in the group? There's a software where you just key in the names of the compound, right? It will generate the drawing. Any one of you have tried? I can see some of you are showing a blur face. I mean, you don't explore it yourself, right? So look back to our WhatsApp message, right? I did share one. I can't remember exactly. I think it's a CHM3301 something like that, right? Which is quite a useful software. Okay, so it helps you how to draw. Okay, there's one more thing. Have you guys received a model kit?
Yes.
If you have received a model kit, right, I want you guys to take up a model kit, then build the model kit, then we'll try to discuss together. Otherwise, I think instead of, I mean, you doing yourself, you know, I mean, just listening to me, I don't think it is a good idea, right? So, yep. So where we stop last week? We stopped at CCI4, isn't it? Is it CCL4? Where did we stop? I remember we covered 4 molecules. We still have another 8, right? Xiaoyan, where did we stop last week?
Last week we stopped until the additional you said CH3F.
CH3N, CH3N, CH3F. All right, CH3F. So this is only the second, isn't it?
This is
let me hold on. I just okay, in the table, where we are in the table?
CH2Cl2.
CH2Cl2, right? Because the table, I believe there's a mistake because CH2Cl, it's not complete. Remember? It's supposed to be CH2Cl2. Okay, so after CH2Cl2, what is the molecule now?
NH3.
NH3 we have not discussed, isn't it? Okay, but somehow we already discussed in the class. Okay, so guys, could you just build your NH3 now? If you have the molecule kits, we'll go through it slowly, right? I want everybody build your molecules, right? And I might ask you to come forward to explain to your friends. Okay, so I'm giving you 3 minutes or 2 minutes to build the molecules and then find your answer. Then we discuss. This one very easy. We have talked about it many times in the class. Okay, 3 minutes. Right. Who has not received the model kit? Who has not received your model kit? Can you raise your hand? Use functions. You use the function in the WhatsApp group. Wow, it's quite a numbers of you guys. Have you placed the order? Or when did you place the order?
Yes.
Week one, you placed the order, or the day before? Harisha, did you place the order for the model kit? Yes. Have you received it, Farisha?
Not yet.
Oh, not yet.
No.
I believe you placed the order through Lazada or Shopee, isn't it? Did you check where the seller from? The shipping from China, I believe. It should be shipping from China. Fatima, dah dapat ke Fatima?
Yes, doctor.
You have got it. Oh, good. Hey, why you receive it earlier, faster than the rest of your friends? 5, did you receive?
Yes, I already received.
Oh, okay. How much you pay for that?
If not mistaken, is 17 and until 19 like that lah.
Okay. So you see, this is the small box I have. I think I bought it maybe years before. This is the small box. Okay, I have another one. Hold on. Another big box. This is very big. Okay, this is very big. Okay, I got the small box and I got the big box. But I think for you guys, a small box will do. All right. There's one more thing. If I share the SCL assignment, I did, isn't it uploaded in the Putra Blast already, right? Have you checked? Okay. Xiaoyan, have I uploaded the, hold on. I think sometimes I better check it myself, you know. Is it there, the SCL topics for your group presentation? There's supposed to be 10 topics for the explanations about the structure.
And there's the SCL worksheet overview and the SCL scoring rubric.
Okay, hold on. Let me see. Yeah. The tutorial is there. The SCL. Oh, I have not. Sorry, I have not uploaded the SCL assignment. Okay, later, right? I will upload your SCL topics, right? Don't worry. It's sort of like quite an easy one because it's all about explanations of the structures. So where you have to choose one particular structure, for example, NSCL, you have to do your PowerPoint explain, and then you have to do your video, right? You have to do a video explanations. Okay, I will upload the topics and how to choose the topics. Okay, I will think put it in the WhatsApp group. First come, first serve. Okay, first come, first serve. It's going to be a group presentations, so 10 marks. So it's quite important. Okay. So, all right. So those already built the models. I believe it's better now we start discussions. All right. Can we choose 5? Can you explain? Maybe you guys prefer to listen to your friends instead of listen to me. Okay.
Okay, so for NH3, its shape is like trigonal, a trigonal parameter lah, because it got contact at here, right? So it's 3 pair, which the hash will go down like this. Okay, so first we see is that it got CN or not. So we see it have 3 disks. Rotate 120 degree. So the NH3 it got C3. Okay. So next we see it got C2 or not. So as we know, it is
C3.
not a planar, so it cannot be.
I think your connections is sporadic. It's not so stable. Okay, never mind. Right. Thanks trying. Right. I think you guys also having difficulty to listen from what
Center.
you say.
So it is like a triangle. Okay. Thank you, Doctor. Sorry.
Yeah. Okay. All right. Okay. Fine. Okay. Good try. Good attempt. Okay. So I show one times. Right. Again. Right. When you want to explain, the first thing you will say, okay.
Doctor, sorry. Boleh Doctor record class?
Hold on. Yeah.
Recording in progress.
So now we are talking about the symmetry for the ammonia, right? The chemical formula will be NH3. Okay. So first thing you have to ask yourself, is it a planar structure? If this is not a planar structure, right? So what is the geometry shape? The geometry is supposed to be, you see, 1, 2, 3 at the bottoms, and then you have 1 at the top. And don't forget, because it's ammonia, right? You should have 1 lone pair electrons. Therefore, the geometry will be trigonal, 1, 2, 3, trigonal pyramid. Okay, the geometry is supposed to be trigonal pyramid. It's very important. You need to know the geometry. Like I say, planar or non-planar, different conformations will give you different point group. Okay, so first we know you could have a principal rotation axis, right? This way. And then you have to decide the highest n value. The highest n value is going to be your principal rotation axis. The line will be the symmetry elements. Your symmetry operations will be C3. So you have to rotate 120. Like I say, it must be 3 of the same kind in order to have C3. 4 of the same kind then only allows you to have C4. Remember that, very important. If you want a C5, you must have at least 5 of the same kind. Okay, right. So, but then we have also mentioned many times, right? So, although it is 1C3, okay, but because it allows you to rotate 120, 240, so your C3 square. Therefore, certain books or in your character table, they straight away will put 2C3. Okay, in fact, we only know it's one axis, but it is C3 square. That's actually telling why 2C3. Don't be confused with that. Okay, when later on we look at the character table, you will ask yourself, why I only have one C3, but why the region there is 2C3? Okay, so this is because of the C3 square, because it's 240. Next thing, does it have M prime, Cm prime? Because since it's 3, so your M prime must be smaller than 3, because you look at the condition, M prime smaller than N. So of course, it's going to have C1, but C1 is nothing, because C1 is actually your identity, 360 degree. So then in this perspective, you have to look for C2. So is it possible to have any kind of C2? No in this case, because it's impossible. Inversion center, it is also not possible. Remember, I told you, right? If you have a TD, tetrahedral, trigonal, pentagons, right? You will not have inversion center. But rectangular, square, parallelograms, okay, those you could have inversion center. Okay, next. You have C2 perpendicular to your Cn. That means, could you find another C2 perpendicular to C3? Because the Cn is C3 in this case, so you will not have. Next, would you have sigma H? Now it's important. Structure like this, okay, one thing, If it is non-planar, because it's not a planar structure, very high chance it will not have sigma H. Okay, if it is a non-planar, very high chance it will not have sigma H. But it is not absolute, because if you look at this one, your TD, your OH, right, your octahedral structure, although it is non-planar, but in this case, it does have sigma H. Okay, but when you try to solve this type of questions, you have to use some logic to think. Okay, if it's non-planar, most likely you don't get, but it is not 100%. Okay, right. So sigma H, no. Sigma D also no. Okay, but if you recall the flow chart I told you before, I show you the flow chart. Remember, if you have Cn, you have C2 perpendicular, then you only look for sigma H and sigma D. Remember the flow chart? If you have Cn, but it does not have C2 perpendicular, it stays as the C group, then you only look for sigma H and sigma V. So in this case, it doesn't even have C2 perpendicular, so you will not think you have sigma D. Okay, yang tak faham, yang tak ingat, okay, try to recall apa yang saya bincang dalam lecture. I kata untuk yang flow chart untuk tentukan point group, kita akan tentu special group kan, yang high symmetry, low symmetry. Kalau dia bukan dalam high symmetry, low symmetry, we will look for the principal axis. Lepas principal axis kita dah tentu, kita look for C2 perpendicular to your Cn, the principal axis. Kalau ada, dia akan jadi D group. Okay, D group, lepas tu cari sigma H. Kalau tak ada, cari sigma D. Okay, atau kemungkinan dia ada kedua-dua. So we only look for sigma H and sigma D. Alright. Back to what we discussed tadi, kalau Cn ada, tapi tak ada C2 perpendicular, dia akan kekal sebagai C group. Okay, dalam C group ni, kamu hanya cari sigma H dan sigma V. Okay, so you look at this case, you only have C3, but you don't have C2. So you only look for sigma H and sigma V. Okay, so in this case, you will know automatically my sigma D is out of questions. Sigma V berapa? Sorry, sigma D tak ada. Sigma V berapa ada? How many sigma V you have? Right, 1, 2, 3. You have 3 sigma V. Okay, you have 3 sigma V. Improper rotations. Can you rotate and then you reflect? It is not a planar structure, so it's impossible. So you don't have. So point group for this?
C3V.
Yes, very good. C3V. Okay. So you could have other similar structures having C3V, should you recall. Okay, if you look at this one, right, it could be CH3Cl or CH3Br. In this case, what will be the point group for this CH3Br?
C3B.
Yes, it will be exactly like C3V because it's having a lone pair, a trigonal pyramid. If you replace one which is different, just take this one like your lone pair electrons. Okay, it's different from the three, isn't it? So the symmetry operations you can perform will be exactly same as your harmonia. Okay, but if you have all 4 same atoms attached to this carbon CH4, CCl4, what will be the point group for this, Natasha? This is what geometry? Kalau 4-4 pun sama, what is this geometry?
Tetrahedral.
Tetrahedra. So tetrahedra is what kind of group?
ED.
For this one? Huh? Farihan?
It's the tetra.
Yeah, if this one is tetrahedral, it's under what kind of group?
TD.
TD, okay? TD is what group?
Height symmetry group.
Special group height symmetry.
Yeah, special group high symmetry, okay? So sometimes if certain kind of questions, come up, yeah, it just basically try to give you 3 marks. Okay, so we have done NH3. What will be the next molecules? CCl4.
H2C, H2C, double bond C, double bond H2.
Hold on. It's supposed to be hold on this one. It's H2CCCH2, isn't it? Is it this one?
Yes.
Okay. Those of you who have molecules, can you try to build one for yourself? If you have molecules, build one for yourself, right? I give you 3 minutes to build, okay? For those of you, if you do not have your molecules, right, also try to think. You can try to script it on a piece of paper, try to write it, try to check. Hold on, that minute. Okay, 3 minutes, everybody, try to work up. You can use this one, the transparent color one, to make your double bond because it can bend. It's slightly longer and it can bend. If I think if you are getting the same model kit lah, like me, okay? If you first time having your model kit, try to check the different color, the balls, right? Certain colors have only one hole. Certain color have 3 hole, 5 hole, and 4 hole. All right. So yeah. Okay. Take your time to build. The formula is H2C double bond C double bond C H2. Jasmine, have you got the model ready, Jasmine? who has got the model built, can you show me? Just raise it in front of a camera. Then I shall see whether you get it correct or not. So far I have not seen anyone be, okay, 5, you have raised it. Okay, good. Okay, right. Try to observe, try to look at the model kit, see whether the question is planar or non-planar. Chapawati, you got the model kit? You don't get it yet. Okay. Jaris 3-1.
Yes, sir.
Yeah, have you got the model kit?
No, not yet.
Yeah. Okay. So try to draw. If you can, try to draw a piece of paper. Yeah. Yeah, you have a very puffy hair, right? Your hair are very thick. Perhaps you may not appreciate what you have now, but when you reach certain age, then you will think, right? Being hairy, it will be like a good thing. Okay. Nafal, you are in the dark.
Yes.
Yeah, it's better turn on the light, yeah, because it's not good for your eyes. All right, look it at the screen over long periods. Unless you wish to be like Jaris lah, wearing a specs. Otherwise, please turn on light. Okay. Right. Anyone else have got the model kit correct? If you have built a model, just show me. Just show me. Okay. Right. I think that's correct. From Xiaoyan. Okay. How about the rest of the students? Okay. Siti, can you just hold it? Okay. All right. That looks good. I believe your model kit looks to be slightly smaller than the one I got though. Can you guys just raise your model kits? I think Xiaoyan's one is almost same size. Yeah, 5 is same size. Is it because of the distance to camera? I think Husna, yours is a bit smaller. Okay, I don't know. Okay, right. Okay, Fatima also got it. Okay, so now if you have not got the model, then you look at this carefully. I will demonstrate one to you. Whiteboard. Okay. This is the structure of the H2CCCH2. It has 2 double bonds. All right. Then first questions. Is this structure planar or non-planar? Xiaoyan, is it planar or non-planar? I heard someone say no. Why you say no? How confident you are?
I think non-planar.
Okay. Yes, it is non-planar. Okay, but should you take a closer look? It somehow looks like a rectangular. Did you see that? It looks like a rectangular, right? So the atoms, you have one atom at this corner, and you have another atom at the opposite corners. So 2 corners here, and then 2 corners here. Okay? Can you see, guys? You see that my finger holding, all right? So 2 corners here, 2 corners here. So the structures actually, it looks like a long, or we call it a rectangular. If you're afraid you forget in your table, you can just write it a rectangular shape. It's non-planar, it's rectangular. Okay. Again, why I say at the outset, you need to determine this because your geometry will affect your point group. Different conformation also affect your point group. Okay, so now, if I try, okay, to look at the molecules in this way, Of course, you can say I want you to hold it in this way. Can, no problem. Okay. We try to look at it from this way first. Okay. So you place it as a rectangular. Where will be your principal axis? First questions. Should you find two of the same kind, two here? Okay. What would you think will be your principal axis? C4? You think you can have C4? No. Okay. C3? No. Okay. You could have first one here. Okay. If you take this is your z-axis, you could have rotate 180. Okay. Right? You could rotate 180. Therefore, this one on the top, we swap the positions to the back at the top. Okay. Similarly, along your x-axis, you swap the positions. Okay. Right. From here, okay, your y-axis, you rotate 180. Okay. So you have C2. Everybody clear? If it's like a long rectangular, right? So in this case, it will be z-axis, x-axis, and y-axis. That will be your principal axis. You can choose either one. Okay, so C2. So the next column, should you have n prime smaller than n, but you only have 2. In this case, we don't regard C1, isn't it? Because C1 is E. So no. Inversion center. Anyone? Nafa? Do you think you have inversion center? Okay. It will be exactly at the center, right? Remember this one from the back. This one from the back, it can go down, right? So this one come here, right? So because it's rectangular, okay? So it does have inversion center because it's rectangular. Remember? Okay, but TD no, right? TD no, but rectangular yes. Okay, next. Does it have C2 perpendicular to your CN? Yes, because if you take this one as your principal axis, this one from this side is also C2, but your C2 also perpendicular to your C2. Yes. Do you understand, guys? I repeat, if this is a C2, you could have another C2 this way, isn't it? Because you rotate these two, isn't it? So this C2 and this C2, they are perpendicular. Okay? So now it's actually changed to D group. Next questions. Does it have sorry. Do we have sigma H? Do we have sigma H?
Yes.
Yes.
Okay. If you say that it has sigma H, let's say I take my principal axis here. My sigma H must be cutting this way because sigma H must be perpendicular. So can you cut this way?
Yes.
Huh? Nakib, you have 2 at the opposite corner. Can you cut this way? Is it same if you cut this way? Because these two and these two, they are different. They are not stacking on each other. You can't cut that. If you put this way, you also cannot cut. It's different. So you don't have sigma H. You regret? Did you get it? 5? I repeat one more time because it's 2 at the 2 and the 2 at the opposite corner because it's like the rectangular shape. Okay. So if your principal axis here, your sigma H must be this way, isn't it? So in this perspective, you can't cut because this one, if you have a middle plane, this one's supposed to be at the bottom here. This one should be on the top. So you can't. Okay. Sigma D.
Sigma D has
How many sigma D?
2.
Because it's already D group. So D group, if you know H, sigma H, you have to look for sigma D. You can cut here, 1,
1,
2.
2.
Can you cut at the middle here?
No.
No. Okay, so you have 2 sigma D. Sigma V, no. Okay, next questions. Could you have N?
N.
Okay, if you take this one, if you rotate 90 degree, okay, your imaginary sigma H here, this one refract here, this one refract here, this one refract here. So you do have
Sn.
S2.
S2.
You do have S2. Okay,
Point group
how many S2 you have?
2.
Can it from this way? Which I doubt so. This way, which I doubt so as well. Okay, so you only have one S2. Point group for this, guys.
1 S2. C.
Naki, can you try?
D2.
Look at the information you have. Okay,
D2D.
C2. Okay.
C2, perpendicular.
So D group. Then
D2.
D2.
D.
Okay, D2D.
There's UE.
Easy, isn't it, guys? All right. Next. What we have? For the next one. Okay, H2O2. This one, I give you 2 minutes. Draw it. This one we have discussed in the class.
Yes.
We already discussed in the class before. Remember the trans H2O2. We have the. Okay, this one I want you to put in the bracket
C2.
planar. Because remember in the lecture we did discuss your hydrogen peroxide, it could be planar or non-planar. Okay, 2 minutes. Everybody draw the build the molecule. Yep.
Yang tadi
Yang apa tu?
yang improper rotation tu kan, kita spin 90 degree and then reflect. So S4 lah kan, Doktor?
Yeah, thank you, Adam. Pardon me. All right, I made a mistake. 90 degree means S4. Sorry. Yeah, thank you. Very good, Adam. You show that you already pay attention. You do understand. My fault. Okay, my fault. Apologies. Okay. You know, sometimes somehow, being an instructor, I also made silly mistakes. Although I told you rotate 90 degree, but I tell you S2. Okay, good. Very good. Everybody got your model? If you have done your model, can you raise your hand, raise it high so that I can take a look? This one very easy. Okay, if you have built it, okay, raise it high. Okay, simple molecules, right? Okay, so make sure it is planar. So if Amirin, can you show me your molecule? Okay, good. Take a look, because since I mentioned planar, okay, Natasha, good. It has to be 1, 2, 3, 4 atoms on the same planar. Okay, I repeat. If you say it's planar, 1, 2, 3, 4 must be on the same plane because they are planar. Kalau satu bend out, okay, they are no longer planar because only 1, 2, 3 same plane, but one is slightly bent out. But why does it happen this way? I've told you because of the lone pair electrons causing the steric repulsions, make one of these bend out. Okay, so that's important. Right. So now, who want to try? Since this one we also have discussed before. Okay, Xiaoyan, can you try? Explain to your friends. We did discuss it in the lecture before.
It's the trans H2O2, so it's a planar, then it can have a principal axis by C2, which is 100, it can rotate 180 degrees.
But you have to hold the molecule, show the positions. Otherwise, your friends could not get it. Okay, right? Okay. So where is it? Your C2? Where is your C2? This way? This way? Or this way?
this way.
Okay, guys, if you hold your molecule this way because it's a planar, the four are the same plane, you can't have C2 here because C2, that means this one will rotate here, isn't it? You can't. This way, can you? No, because it rotates, it will come down. This one come up. No. The only possible C2 for you would be from this way, right? You rotate 180. Okay. Try to having the habit of counterclockwise, counterclockwise. Okay, because I told you counterclockwise rotation, we take it as positive. Okay, so you have one C2 here. Next column, Xiaoyan, what will be your answer?
Since it's C2, so it will
No CM prime, right?
no CN prime.
Okay, inversion center.
Yes.
Okay, where is your inversion center? Yeah, exactly at the middle between the two oxygen bonds. So this one travel equal distance, right? In the opposite, equal distance, opposite direction, one top, one at the bottom. So it does have one inversion center. Next column, does it have C2 perpendicular?
No.
No. Sigma H,
Two.
does it have sigma H?
Yes.
Where is your sigma H?
Some other.
Can you show? Your principal axis is here. Remember, the principal axis is here.
So that's
If you have sigma H, where should you cut?
Perpendicular.
It should be here, isn't it? Perpendicular, right? So this plane is perpendicular to this. Okay, so you do have sigma H.
Oh.
Do you have sigma D?
No.
No.
No. Sigma V, no need because you know already in the D group. Okay, next. Does it have improper rotations?
No.
No. No.
If you want, okay, this is a C2. This one, okay, I rotate C2. My imaginary sigma H here, this one refract to the bottom. This one refract to the top. So in this case, what will be your improper rotations?
S2.
One S2. Repeat. If you place the axis here, you rotate 180. Okay? Your axis is vertically. Your imaginary sigma H here, this one refract to the top, this one refract to the bottom. So in this case, it does have S2. All right, so what will be the point group for this, Gavin?
C2H.
C2H. Okay, guys, now you take a look. From the 3 molecules that I show you, did the improper rotation affect the naming of your point group in normal circumstances?
No.
No.
No. No. That which molecules that we have discussed before, it does affect your naming point group? We discussed in the lecture. This one looks a bit complicated. The 1357 tetrafluorooctadiene, remember that one? You could also have C4. Remember, you have C2, but you could also have S4. The point group is S4, remember? The 1357 tetraoctadiene. Okay, but I emphasize in most of the circumstances, your improper rotation doesn't really affect your naming, but it is not 100% sure. Okay, it's not absolute. Except like the special one we have seen, 1357 tetrafluorooctadiene. That one, yes, because the point group is S4. Okay, so let me get this one, cis. This planar, this way. So that means now, guys, you see 1, 2, 3, 4 on the same plane. And now 2 hydrogen, both at the bottom. So in this case, what would be your principal axis? You can just twist a molecule. Should you have your molecule ready? Okay. So your principal axis, see what?
C2.
C2.
Yes, it's going to be from here, all right? 180 C2. Okay. Can you have a C2 this way? Can
No.
you? Because if you rotate, then we both go up, isn't it? No, impossible. Can you have this way? If you rotate, both also will move out. So you only have one C2 here. CM prime, I know C2, no need to look at it. Inversion center? Okay.
No.
No, because both at the bottom, no. C2 perpendicular, you only have one C2, is impossible. Sigma H, if a principal axis is here, your sigma H must be this way, isn't it? Because it's perpendicular. So in this case, other? No.
No.
Okay. So you know it doesn't have C2 perpendicular. You no need to look for sigma D. You only look for sigma V, remember? Okay, so in this case, how many sigma V? 1, 2. 2 sigma V, let's just write 2. Okay. Improper rotations. If you want to put it this way, okay, should you rotate C2 and then you have refraction both down? It could have. But the first question is, it can't actually have S2, isn't it? Oh, hold on. Just now I told you this one. All right, it reflect, yes. Okay, so it'll be same concept. Okay, so if you this one, you have a C2 here, you rotate both up. Okay, and then your sigma H will be here if it refracted. Yes, it could have S2. Did you follow me? If you, no, it's not, because it reflected up. Then this one refract is no longer. No. Sorry. Okay, guys. Okay. Sometimes you need some logic to to analyze. If I put a C2 here, all right, I rotate 180. I need to have an imaginary sigma H. This one reflect, but these two now stay at the top. It's no longer at the bottom. So no, you don't have it. Okay. If this way, also impossible. So it doesn't have any improper rotations. Okay, whereby just now we say the trans. Okay, we say the trans. Okay, so if you rotate C2, yes, right? Because this way your imaginary sigma h here, this one reflect to the bottom, this one reflect to the top. So yes, but this one no. Okay, what will be the point group?
C2V.
C2
V.
V. Okay, C2V. Very easy. C2V, very easy. Okay. If let's say trans, okay, H2O2 non-planar, 1, 2, 3, same plane, but this one bend out. So nothing else you have except you have a C2. Okay, so point group for a trans H2O2 is C2. I repeat, okay, trans H2O2 non-planar will be C2. Okay. Next, what we have?
Trans.
Okay, 135 trichlorobenzene. Okay. Okay, whether you have you can try to build 135 trichlorobenzene. Everybody, I give you 3 minutes to build. I'm not sure whether you have enough. You have enough this transparent one which can bend. I think the small kit I have, it doesn't have sufficient of this you know. Yeah. No, I didn't have enough. Okay, never mind. I need a whiteboard. Can I just have a new separate one? I think this one you have copied down the answer, right? I think perhaps I just remove everything so I could have a new one. Erase or clear all. Okay. You guys ready? Now we try to see this, the 135 trichlorobenzene. I'm sure you guys may have heard about why a benzene. This is a benzene, all right? A benzene molecules, organic compound, carcinogenic, and in most of the lab, benzene has been banned. We don't use benzene anymore because it's carcinogenic. And speaking of the chemical safety, we replace it with methylbenzene, which is less carcinogenic compared to benzene. So this structure, it has a very interesting origin. It is named as Kiko structure. Have you heard about this Kiko structure? No. Nagib, have you heard about this story?
No,
The Kiko structures actually, there's a scientist, I think his name it will be Kiko, I think. This is why the name is a Kiko structure. He has tried to solve the structures for this because benzene is C6H6. He tried to solve the structures, but because you know every carbon, it has to be 4 coordinated. So how did this guy figure out this structure? Because it's a cyclic. So it's the incident he noticed that a snake tried to bite its tail. This somehow give him the inspirations. It's just like a snake try to bite its tail. It give him the inspirations. Okay, it's going to be a cyclic structure. And at the end of the day, he sorted out this. In certain circumstances, when people will just write it as this. Why people write it as this? What is the sphere inside indicate?
Double bond that can move.
Yes, it is the delocalized electrons.
Delocalized.
The electrons in the double bond delocalized. Remember, for this one, okay, what kind of chemical bond between this and this?
The electron on double bond.
Yeah. Right, because ideally it's supposed to be this way, isn't it? You have to, right? Between this, what are the chemical bonds? This one, what are the chemical bonds involved? Hey, organic chemistry though, you guys told me. You love organic. If you have 3 sigma bond and you have 1 pi bond, isn't it? Because in the double bond, it should be the pi bond. Okay, so again, sometimes people try to look at this one. What's this? It's like a tortoise. Okay, it's like a tortoise. So now what you have, now I start to appreciate how nice I have a touchscreen computers. So it is a 135 trichlorobenzene. Okay, so should you want to describe the structure, it is going to be plain, and then it has a cyclic structure. Okay, cyclic 6-member ring. It has a ring structure lah. Okay, clear. So you have a table. So where will be the what will be the principal rotation axis? It's a line perpendicular to this screen, isn't it? So you have to rotate 120 degrees. So this is going to be your C3. Okay. So so your first column, your Cn will be C3. It can't have C6 because in the presence of the hydrogen and the chlorine, they are not the same. Kalau semua hydrogen, kalau semua chlorine, I don't think it exists, this molecule. So you can, if you're all hydrogens, yes, you could have C6, but not in this case because it replaced by or substituted by chlorine. Okay, next column. Do you have M prime? Right, the M prime smaller than N. Now you have C3. C1 is definitely out. The only possibility will be C2. So if a C2, how many C2?
2.
One
C2? Only one C2? You sure?
Ready.
C2. C2. It has
2C2.
3 C2. Okay, so you fill out. You have 3 C2. Next, inversion center. Does it have inversion center? If you think you have inversion center, this one CI want to go this way or go this way, you will not know. So impossible. No inversion center. Next, any C2 perpendicular? Yes, we do observe just now. This because this one perpendicular to the screen. In fact, it is something like this, isn't it? So this is a C3, this is a C2. They are perpendicular. Okay. So now it stay as C group or D group?
D.
D group.
Yes. D what?
D1.
D2, D3?
D3.
Fine. Yes, D3.
Oh, D3.
Because your principal axis is C3. Now your C2 perpendicular. So it's going to be D group, D3. Next one, sigma H. Does it have sigma H? Yes, because you know this is a planar, isn't it? It's planar structure. So it does have sigma H. Okay, so now you know it's D group. You only look for sigma D. You don't look for sigma B if according to the flow chart. Okay, so how many sigma D you have? One. It's just like your C2. One, two,
3.
three. You have three.
3.
You have three sigma D.
Sigma D.
Okay, next. Sigma we know. Improper rotations.
Improper rotation don't.
Yes or no, Nagib? Improper rotations?
No.
I think no.
Ada.
You think no? You did not remember my message.
Boleh.
Yes, it has C3. Remember that day I post in our group, I say no, but in fact it is. I show you the drawing in our WhatsApp group. In fact, it is also this point, but S3, right? Remember, because we did consider for the planar structures, all right? Because this one, if you had S3, that means C3, you rotate here, then you have this imaginary sigma H. You do consider the atoms, even though they are on the plane. Okay, so it does have one S3. Point group for this, guys.
D3.
D3D.
D3D.
D3D, D3H, because your sigma H, isn't it?
Oh, D3.
Sigma H come first. So D3H.
H.
Point group will be D3H.
Dia ada.
Guys, you have to know how to draw this one. You need to know how to draw because in your exam, you need to show the drawing. The drawing gives marks. Okay, your drawing gives marks.
To show the drawing.
Okay. How many more we have? Oh, we should have 1, 2, 3, 4, 5, 6. Okay, I want you to build B2H6. All right. I have now it's 10:15, so we come back at 10:30, right? So we will continue the rest of it, right? We take a rest, we come back at 10:30, all right? I want you all try to find the answer for B2H6 as well as the cyclohexane boat. I don't want just to give you all the answer from me. I want you to build yourself, right? Try to get B2H6 and cyclohexane boat confirmations, the answer. Okay, right? We shall discuss 10:30.
Recording stopped.
So we will stop at, I asked you to work on the B2H6, isn't it? Right, okay. Can somebody show me the B2H6 model which you have made? Can somebody show me? Okay, I just disable this one, stop sharing. Okay, show me your B2H6. Your B2H6, guys. You guys got it? Mm-hmm. Okay, fine, you got it. And then next, Cairo, can you show me again, Cairo? Okay, good. Cairo, B2H6. Okay, so I might need another one. Hold on. Where is mine? Okay, so some of you have not received the model kit in time, right? So okay, I just take this one a bit better. Take the black one. I miss my, hold on. I miss my purple color. You know, sorry. Miss it. Okay, it is two. The yellow one. Sorry, guys. It's a bit delay. You know, sometimes the moment you want to look for something else, you may just cannot find it. Okay, so the black one, I just check this. Okay. The first question is the structure planar. Those already built. Do you think the structure planar or non-planar? Mm-hmm. 5 is the structure planar or non-planar?
No.
Yeah, but these structures is somehow a bit special. Why is it special? Why this structure is a bit special? Because it does form what?
Yeah.
Rectangular.
Yeah, it is actually, right. Okay, so guys, now look at it. This is a structure that we get. It is actually a diamond structure.
Oh.
Why we call it a diamond structure? I'm sure you have heard about this. Remember, like ALCL3, ALF3, whatever. So because this one, the boron actually from group 13. So boron tend to form electron deficient compound. Okay, because if you look at your BH3, whatever, you know, it tends to form electron deficient compound because simply it has 3 valence electrons. But in order for it to achieve octet, it forms a dimer structure where this is what you see now. Okay, which is what you have seen now. It has formed a dimer structure. Okay, so you can take a look like this, but you know, so you have 4 in the same plane, and then you have another one here, right? Okay, or you want to tweak it slightly, it's just a rectangular, but I think it's good to hold this 4 in the same plane. Okay, so if this is the case, where will be your principal axis? Guys, the model actually is supposed to be this way, though. Okay, it's supposed to be in this way, right? Repeat, guys. Your model is supposed to be, okay, 1, 2, 3, 4, right, on the same plane, but the other one actually at the different corner. You get what I mean? It's like a rectangular. Okay, it is like a rectangular. So you have a B, so this one here, H, 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 H. Get it? Do you follow me? B2H6, right? It is a bit similar to your H2C, your H2CH2, but in fact, this two will be here, right? Okay, so you have 4 here. So you have another one here. So then you have the B, and then you have your H, B, H, all right? Is that a rectangular? Okay, so if that's the case, okay, so your principal axis will be here. So you rotate 180, just like a C2H6, because it is like, okay, it's very difficult to bend. Okay, guys, do you copy that? I better twist this one because this one it cannot twist. Okay, okay, all right. So because this 4 actually same, but you have another, the 4 corners. All right. So you're gonna have 1. All right. 2 as well. Okay. And then this way you also can rotate. It is exactly like your what do you call that? Your H2CCH2. You understand? Did you follow, guys? Because these two, this B, H, H, they are actually on the same plane, but these two at the opposite corner, just like your, your H2CCH2. Okay, so you have 3 C2. First one, the principal axis will be C2. Okay, and then NC2, the M prime. M prime, no, it doesn't have an M prime. Inversion center. No, it's an inversion center. The third column is inversion center, right? It does have inversion center. And then C2 perpendicular. Yes, because it's all 1, 2, 3 are the same. You have 2 C2 perpendicular. And then sigma H. Does it have sigma H? You think so, 5? For your H2CCH2, do you have sigma H? Imagine the 4, they are at the opposite corner, so you will not able to get your sigma H, just like your H2CCH2. You don't have sigma H, okay? But you do have your sigma
vertical
D. You do have the sigma D, 1, 2. You do have 2 sigma D, all right? But this one you can't cut because you can't cut this way, okay? You do have 2 sigma D. And then sigma V, no. Okay. And then next, improper rotations.
improper rotation.
Yes, it does have improper rotation. It has three S. It has 3 S4 as well, right? Just like H2CCH2, it does have S4. And then next,
Point group.
is the point group for this. We have C2 perpendicular. So this one will be D2, D2D. Just now your H2CCH2, what is the point group?
D.
D2D also.
Also D2D. Okay, right. So this one is quite similar. Okay, so now the next one. What is the next one? Cyclohexane chair conformation, isn't it? Okay. 1, 2, 3, 4, 5, 6. Okay. These are having a ring structure, or they are cyclic, 6-member ring. Okay, so which one is chair, which one is boot conformations?
Rabu. Okay.
The left one is chair.
The
Left one is chair, okay, and then boot.
The second one, the right.
The second one.
Okay, so have you guys made the structure? If you have not made the structure, do it now. If you have done your cyclohexane chair conformations, can you show me your chair conformations? If you have not, take 2 minutes to do it now, quickly. It's very easy. First question, does it have double bond? Does it have double bond? No, because it does not have double bond, just like the one you have seen in your 135 trichlorobenzene. Okay. Ignore the hydrogens. Okay, so now guys, look at it. This is like my drawing. Remember, this is the left one is chair, because you see this is like the the leg. This 1, 2, 3, 4 on the same plane, and then you have one at the top. This is the back and the leg. So this is a chair conformation for your C6H12. But if you have a boot, so this is a boot, because you bend up, the boot is like both sides, right? You have this pointing upwards, all right? So this is a boot, this is a chair. So we will see the first one, which is the chair. Okay, if you have built the model, okay, lay down your model on the table. Put down your model on the table. Okay, so now try to lift it parallelly. Right? If you lift it up, so now you will see, literally, you have 1, 2, 3 on the top and 1, 2, 3 below. Did you observe that? Okay, I say chair conformations. You built it, put it on the table. Okay, now you see you find out 3 on the top and 3 at the bottom. The base is actually 3 atoms, 3 carbon atoms. Another 3 will be on the top. Did you see that? Okay, if I raise it high, it's supposed to be this way, right? 3 on the top, 3 at the bottom. Okay, so this is your chair conformations for cyclohexane. Those receive the model kit later on, you can try to build and try to visualize yourself. Okay, so now, where will be your principal axis? Is at the middle of the ring. Because now I have 3 on the top and 3 at the bottom. So at the middle of the ring, I can rotate 120 because I have 3 of the same kind on the top. So I have a C3. Next, do I have N prime? C3. So now C1, I have to look for my C2. Does it have C2? It has 3 C2. Where is it? Okay, guys. Now look at my illustrations. I have 2 here. You see 2 at the front and 2 at the back. Should you look at it, you will see this is like a slanting plane. 1, 2, 3, 4 on a slanting plane. Okay, so if I put an axis here between the middle, so I can actually rotate 180. Okay, so these 2, right, And then I take from this angle, these two, and these two are actually on a slanting plane. Okay, so the other one, so 1, 2, 3. Okay, so it has 3 C2. Did you observe it, Xiaoyan? Did you find the 3 C2? I repeat, if you have whole your molecule, 3 on the top, 3 at the bottom. So C3 here at the middle, but your C2 that you have to look at that is 1, 2, 3, 4. They are actually on a slanting plane. They are dalam satu sata yang condong. Okay, so you put a C2 here, you rotate 180. Okay, you rotate 180. So these 4, and then these 2, and these 2, another 4, and then you look from here, another 2, another 2. So you actually have 3 slanting planes. So that is where your C2 found. Okay, so next, inversion center. It does have inversion center. Remember, you have the one at the top, all right? Hydrogen at the top, you have another hydrogen at the bottom. So the top will move through the center, goes down. So it does have one inversion center. C2 perpendicular to Cn, yes, it has. Sigma H, yes or no, sigma H? No, because it is non-planar. You can't cut at the middle. So no sigma H. So sigma B is definitely out of question. So sigma D, do you have sigma D? Do you have sigma D? Yes. 1, 2, 3. It's exactly like where you're having your C2. So you have 3 sigma D. Improper rotations. What? Just now you say you rotate 120, okay? But now at same axis you only rotate 60 degree. Okay, initially I have nothing on the top, I have one at the bottom. Your imaginary sigma H at the middle, this one refract to the bottom. So you do have one S3. Okay, I know some of you having problem to visualize because you don't have the model. Okay, so you can do it later on yourself. Okay, it does have one S3. So point group for this.
May I ask, this one is S3 or S6?
Thank you. 60 degree S6. Thank you. Yeah, I don't know what I'm thinking. Okay, apologies. So it has one S6. So point group for this one. C, then you have C2 perpendicular, so it becomes D group. D3.
D3D.
D3D, because it doesn't have sigma H. Okay, so now we try to look at the analogous one, which is this one will be very quick. I want you to build, not build, like just to twist it slightly. So you see this is your cyclohexane boot conformation, because now you can see you have 2 on the top. You have 4 at the bottom. If you put it down on your table, you shall see the 4 will be sit firmly on the flat surface, isn't it? Okay, so those who have built a model, you see the bottom 4 could sit firmly on a flat surface. So you have the 2 on the top. So this one, easy. This one, easy. So again, your principal axis will be at the middle. So since you have 2 on the top, you just rotate 180. Okay, so your principal axis for this will be C2. The next column, M prime, no need because your C2 inversion center, you have 2 on the top. How do you go opposite direction? No. And then C2 perpendicular, apart from this one, you can't have it here because 2, if you rotate, will comes down. So you don't have. So you don't have C2 perpendicular. Sigma H, definitely no, because it is not planar. Okay, so the next thing, you don't need to look for sigma D because you don't have C2 perpendicular, right? So you only look for sigma V. So how many sigma V you have? 1, 2. You have 2 sigma V. I repeat, 1, 2 sigma V. Okay, next. Improper rotations. Because now you have two on the top. If you want to rotate and reflect, the two will be comes to the bottom. So you can't have improper rotation as well. Impossible. You see this one. If even though you say S2, come imaginary, these two will reflect down. So it's impossible. You wouldn't have it. Okay. So what is the point group for this cyclohexane? Both conformations.
C2V.
Yes, C2V. Okay. Easy peasy. So you have observed that different conformations give you different point group. Okay, so therefore it's very important before you determine the point group, you should know their geometry. Planar, non-planar, linear, non-linear, and tetrahedral, octahedral, or etc. Okay, so that's important.
Recording in progress.
I forget to record. So next one. SiCl4, S8, SF6. Okay, SiCl4 will be very easy because it is TD. Okay, I have actually shown you at least 2 times. SF6, we also have discussed it in the lecture. All right, the octahedra. So these two, I'm not going to show you, but we would talk about the S8. Okay, now we talk about the S8. Can somebody tell me why S8, the sulfur, it form a rather interesting structure like this? Can you build S8 yourself now? And what properties which allow it to form S8? And what types of chemical bonds you would think it happens? You learned it. You learned it during CHM3301. It's forming a molecular crystal. It's forming a molecular crystal. We call it this is a molecular crystal. What is the color for the sulfur? Yellow in color, isn't it? Yellowish. All right. This is forming a molecular crystal. If you have your cyclohexane, you don't need to dismantle it. It is still having a ring structure. So then you just have to, twist a little bit, then you can have your S8. Who has got the answer? Who have built the structure? Have you built the structure? I give you the hints. It is related to the cyclohexane chair conformations. If you follow me closely, you should know what I mean. It is similar to your cyclohexane chair conformations. Who has got the model built? Can you show me? Let me see whether you get it correct. Okay, very good, Carol. You got it correct. Last one. 5. Can you hold it properly? Let me see. Okay. And who else? It's such a pity if some of you have not received your model in time. Shazmin. Nur Shazmin. Nur Shazmin.
Sorry, Doctor.
Yeah.
Dari tandas.
You pergi tandas all the time. Your camera off all the time. Okay, so next. Okay, so I told you it is similar to cyclohexane chair because when you build it, it looks like a crown. Because inevitably, it's like you have 1, 2, 3, 4 at the bottom, 4 on the top. If you recall, I explained to you your cyclohexane chair, 3 at the bottom, 3 on the top. So this one, exactly. You build this one, it is like a crown shape. You place it down, 4 will be on the same plane, 4 on the top. Okay, so this is a cyclic crown shape. Okay, but back to my question, why does it form as for sulfur form SA? Anyone know the term we use it?
Maybe it can it disobey the octet rule, so it can expand to SA.
This is actually beyond the octet rules. This is forming a molecular crystal. But anyhow, good try, Lau. Have you remember this one? Catenations. In your CHM3301, we covered it. It's the ability to form bonds between the atoms. Catenations. Okay. So this is a molecular crystal. Okay. So now, since we know it is analogous to your chair conformation cycling, again, it is going to be principal axis at the middle. So you have 4 on the top. So that means you rotate 90 degrees. So your principal axis will be C4. All right, your principal axis will be C4. Do you have C3, C2, C3? Which I don't think so, but you do have C2. How many C2 you have? Okay, it has to be same as your, you have to take an opposite pair. For example, if I take from these two, one up, one down, I have to put an axis, then I rotate 180. So altogether, 1, 2, 3, 4. It's going to have 4 C2. It's a bit difficult for me to show you, but I think you could see. Okay, now you look at what I'm holding. I'm holding these two, another two. So they are on the, one is this way, the other two, it's like on the slanting plane like this. Okay, so if you put a line through at the middle hit there, sorry, anyone, someone say something? Okay, I show you this one, you see this one, I'm holding this one, you see these two? And these two, they are, you see, the one at the back, they are actually tilted. They are opposite in the directions, two slanting planes. So you put an axis here, so you rotate 180. Okay, so altogether, you have 4 C2. All right? Then inversion center, it does have one inversion center. Okay, it does have one inversion center because if you take these two on the top, hydrogen here, go through all the way to the middle, go here, it will move down. So it does have one inversion center. C2 perpendicular to Cn, yes. So now it changed to D4. Because your C2 perpendicular to your C4, yes. So now it becomes D group, D4. Does it have sigma H? In this case, no, it's impossible because just like a cyclohexane chair, it's non-planar. So no sigma H. And then now you only have to look for your sigma D. So your sigma D, easy peasy, you also have to cut 1, 2, 3, 4. You have 4 sigma D. So if you have counted that, ignore the sigma V. And then it does have improper rotations. In this case will be how many degrees? We have one that will be S4 as well, right? It has one which is S4. From 1, 2, 3, 4, you rotate, right, S4. So why don't you consider that as S2? Because your S2 and S4, they are full on the same axis, so you only take S4. Okay, so point group for this, since you know it's C4 and C2 perpendicular, D4, it does not have sigma H, it does have sigma D, so this one will be D4D. Cyclohexane chair conformation just now, you see is D2D. Okay. Now you see.
For this one, Sn is S4 or SA?
Okay. It's 45 degrees, isn't it? Yes, it's S8. Yes. Yes. It rotates S8. Sorry. Thank you. Thank you. Pointed out me. I don't know what I'm doing. It's S8. Okay. Thank you, 5. Apologies. It's S8, not S4. Sorry. Okay. Apologies. It's S8 because you put it at the middle. Okay, now you see one on the top, one at the bottom. Okay, so you actually rotate 45 degrees. Okay, so initially you have one at the bottom. Okay, so now it stay at the top. So you put an imaginary plan. This one reflect to the bottom. So it's S8. Okay, so point group D4D. But what I want to highlight to you, see the similarity. This one is D4D, one is D2D. One is 6-member ring, one is 8-member ring. Okay, so for SF6, I don't think I need to show you because it's octahedral. We have taught it in the class at least 2 times. Why is it octahedral? Because you have 8 planes. Remember, you have 3C4, 4C3, 6C2. All right, a 6 sigma D, you have 3 sigma H. That would be your outputs to find them all because SS6, SICL4, those are high symmetry. We have talked about it many times, TD and octahedra. These are special group. When you see this one happens, so it will be TD and OH. Okay, so it's exactly about 11s. I told you today we were able to end early 11s. Yeah, maybe it's the time for me to take a good rest. Yeah, I still have another 3 hours lecture in the late evening today. I hope this, somehow, will allow me to last. Okay. Tonight will be an interesting topic where we talk about X-ray diffractions. And I cover some of these topics about the structures with the master students, the unit cell, unit formula, and etc., which we will learn it in the topic 3, packing efficiency, 74%, 68, 52, all those things, TD hole or OH hole. We'll learn it. Okay. Any questions? Do you have any questions?
No.
No? I hope it is clear. Clear enough? Clear enough? If you're able to do this part, that means you truly understand the first topic. Okay? I have seen some of you actually did quite well, right? If you're able to rectify my mistakes, that means you really follow. Okay? I don't know what happens. It's making silly mistakes. Okay? Right. No questions? Then we shall.
Recording stopped.
We stop today. Okay? We stop today. Right. I foresee next week I will start with the experiment 2, which I probably have not got enough time to start the lecture. But we will check it for during the lab. That is where we learn about the lecture. Many times I say you are lucky because you are having the same content, you're learning it at least twice of the lecture. Okay? So kalau tak faham, it's probably or mainly because you did not put enough effort. Clear? Semua okay? Any interesting things you want to share, or somebody so in a good mood want to sing us a song? Don't kill me softly with your song, guys. You heard about this song before? Killing me softly with your song, whatever. I feel like sometimes I'm talking to, tunggul. Kan tunggul kan in Malay dia macam tunggul lah. It's like a wood piece lah. Talk to you guys macam pun tak ada no reactions. But I ask you one thing: if you're in your house, your mom talk to usually your father, the guy will be the one who's actually a bit quiet, and the mom will keep on talking. Right? So what will happen if your father like keep silence, giving any response, your mom will be go what? Huh? Shamiro, what will happen to your mom?
My mom will get angry.
Yeah, your mom will get angry. Of course, dia akan apa tu? Naik darah lah, makin hamun kan? Yeah, of course, the same thing. I'm talking to you, you don't want to give me a response. Kan? The worst still, some of you even refuse to show me your face. Okay? So yeah, so if that's the case, again, thank you so much. Do your homework, do your revisions. Okay? Download the tutorial questions, do it yourself. Okay? Do it. This one definitely you need to do some practice. Okay, I hope over the weekend you can receive your model kit and then you can start to play around when you have this model. Look at the answer we have in the table, so you can do it. Boleh? Semua boleh?
Boleh.
Jangan cari tunggu lah. Okay? Okay? If you cari tunggu, I naik marah, I will burn you, you know? I'm just kidding. I not to burn you. Okay? So, yeah. I'm smart. I did not record it. Otherwise, you will say, ni Dr. Tan threaten nak kill saya. I don't want later it will come out in the Facebook. A